Good day, everyone. Welcome to Chemistry with Professor John. All right, we will be discussing compositions. Chapter 3, that's composition of substances and solutions. Okay, now it's a good idea to have a periodic table with you because they will come in handy. This is General Chemistry 1, Chem 201, by the way. We need to look up the atomic weight for each element, okay, to figure out the formula, mass, and also molar mass. All right, let's get right on to it, okay? For example, here's an example for water. Water, you have two hydrogens and one oxygen, right? So if you look up hydrogen, it'll be 1.01 AMU. That stands for atomic mass unit. And you multiply that by 2 plus 1 oxygen. That's 16 atomic mass unit. Total 18.02. Okay, if you do that for, if you do the same for P4, this is P4, that's phosphorus. You look up P4, it should be 30.97, you times 4, and it should be 123.88. Okay, that's another thing we should have with us all the time. That's a scientific calculator, okay? Water, oh, we already did water. 18.02 AMU. Well, here's a good one, calcium nitrate. If you look carefully, there's one calcium, there's two nitrogens. Because you notice that it's nitrate, parentheses, 2, okay? Now, there's only one nitrogen, but parentheses times 2, that's why 2 nitrogens. Now, how many oxygens are there? There's 3. You guys see NO3, there's 3 oxygen, but parentheses 2, let's make it 6 oxygens, right? All right, so that's calcium. If you look it up, it's 40.08 plus 2 nitrogens, 14.01, plus 6 oxygens, 16. Okay, do your math correctly. It should come out 164.10 AMU, okay? Similarly, if you guys do for acetic acid, just add everything up, okay? All the atomic masses, all the atomic weights add up. Don't forget the subscript, how many of them. This you should get 60.06. This one, 12 carbon, 22 hydrogen, 11 oxygens, 342.34. Okay, you add them up correctly. Now, molar mass is the same numbers. Okay, for water, molar mass is mass of 1 mole. And it's the same number as the formula mass. It's also 18.02, except this time we don't call it AMU, we call it RAM, okay? So molar mass is RAM per mole, all right? And it's the same as the other one. It's sum of atomic weight of all elements in a compound. If there's a subscript 2, you multiply it by 2. 3, you multiply it by 3, okay? Now HF There's only one hydrogen and one fluorine. So we're going to take hydrogen 1.01 plus fluorine. So 19. So what? 20.01 gram per mole. Okay. Ammonia, we have 1 nitrogen plus 3 hydrogens. So that's 14.01 for the nitrogens. Uh, 1.01 for the hydrogen, but we got to multiply it by 3. And that make it about 17.04. Okay, if you guys do the same, 1 hydrogen, 1 nitrogen, 3 oxygens. That should be 63.02. Okay. Hydrogens, 3 oxygens. Silver sulfate, you got 2 silver plus 1 sulfur plus 4 oxygens. Plug in all the numbers, look up the atomic mass, plug in all the number. $311.81. Okay, so that's how you figure out molar mass. All right. Now, one mole, also defined as Avogadro's numbers. For an element, we call it atoms. For a compound, we call it molecules. Okay? So the Avogadro number doesn't change. It's 6.022 10 to the 23rd power. Okay? You have 1 moles of water. That's going to be 18 grams. And 1 moles of water also equal to 6.022 10 to the 23 power molecules. All right. Okay, so keep that in mind. That is known as Avogadro's numbers. Okay, so let's do some conversions. We're going to be converting 2 grams of carbon. How many mole? Okay. And here's what we do. We're going to take 2 grams of carbon, and you look up on a periodic table. What's this? The atomic weight of carbon. It's actually given right there. 1 mole, that's what atomic weights mean. 1 mole equal to 12.01 gram. That's what it means. You take 2 divided by 12.01, you should get 0.17 mole of carbon. How many molecules? Wow, okay, not moles, but we need mole first. Okay, 25 grams. Well, this one right here, if you do molar mass, just like we did it before, you gotta get 6 carbon plus 12 hydrogen plus 6 oxygen. They should add up to 180.18. If you got a problem, talk to me in the class during the lab time. I'll show you guys, okay? But that's a molar mass of C6H12O6. Now, you got 25 grams, 1 mole, 180.18 grams. That's what molar mass means. And that will give you 0.139 mole. Okay? If you use Avogadro's number, that's Avogadro. And that will give us how many molecules. Avogadro is all about molecules and atoms. So if you do your math correctly, it should come out 8.36. Ten to the 22 molecules. Okay. Determine the mass of each of the following. Okay, KOH. We need KOH, molar mass. KOH is going to be K plus oxygen plus hydrogen. If you look up at a periodic table, K is 39.10. That's the atomic mass for K. Oxygen 16, hydrogen 1.01. So it should be 56.11 gram per mole. So we got 1 mole. Notice I put 1 moles on the bottom so we can cancel out, is 56.11 gram. We just calculate that. So that number 56.11 does not come from nowhere. It's the molar mass of KOH. So you do that, it come out 0.819 gram. Final answer. Okay. Same principle. We need to figure out molar mass of C2H6. Gotta add 2 carbon plus 6 hydrogens. Molar mass is 30.08 gram per mole. So you got 10.2 mole, 1 mole, 30.08 gram. That should give us 307 gram. All right. Again, we need molar mass, molar mass, molar mass. Molar mass. Okay, so after you guys get all the molar mass, you should be able to calculation, do the setup just exactly the same as above. I can tell you what molar mass for this one is 142.05. 142.05 molar mass. We did this earlier, 180.18. I want to say 18. Molar mass of this one, 367.52. 267. Molar mass. Okay, so if you get all that done, this one should be 0.23 grams. Answer. A lot of RAM. It's like 1.235. That's a lot of RAMs. And the third one, $765 RAM. All right. Okay, so that's good practice for mole calculation stuff. Now, percent compositions. Yeah, let's get to that. Let's get to that in the next video. Percent compositions, and then we're going to try to find empirical and molecular formula based on the percent compositions. you can go from that to that. All right, guys, thank you for watching, and see you again soon.